Good evening, guys. Okay, let's start a class. Okay, so in the previous class, we have learned about multiplexers, right? So, what is multiplexers? Can anyone answer in the chat? What we discussed about multiplexers in the last class? Okay, we will just make a quick revision of the previous class. Okay, so multiplexers means like it has which some has many inputs and only one output, right? So it selects one input and sends to the output using select lines. Okay. So what is the relation between input and select lines? It is 2 to the power n, right? Where n is the select lines and 2 to the power is number of inputs, right? So today we are going to learn about a opposite circuit called demultiplexer, which is also known as DEMUX. Okay. So without wasting any time, we will dive into the demultiplexer. Okay. So what does demultiplexer means? Demultiplexer takes one input and multiple outputs. Okay, and using one select lines. Okay, using a select lines. Okay, just like multiplexer, demultiplexer is the same. Whereas it has many outputs. Okay, but only one input. Whereas in multiplexer we have many inputs but only one output, right? So like while explaining, I told that demultiplexer are opposite circuits, right? So it is opposite to multiplexer. So for multiplexer we have only one output, whereas in demultiplexer we have many number of outputs. So okay, you got that point, right? So difference between multiplexer and demultiplexer. So see here. So what happens in demultiplexer? It sends the input to only one selected output. Okay, so we are in demultiplexer we have n number of outputs. Okay, think that now you are passing one input value is coming okay, and in demultiplexer there will be a select lines, right? Just like in multiplexer. So what does these select lines do? These select lines will select one output where that input will be uh, passed. Okay, so all the other outputs in demultiplexer become zero. Okay, if select line select first input, then all the other output other than first output will become zero. Okay, so for a good example for this multiplexer, think you have one water pipe connected to four tanks. Okay, like in your home you have four water tanks or some four sink. Okay, uh, now only one water pipe is connected for all these four or two tanks or sink. Okay, so in that, if you like nowadays we for tank we have switch, right, to turn on and turn off the water flow to the tank, particular tank. So just like on based on that topic, if it switch decides which tank to receive the water. If you turn on the switch, means it will test, oh, I'm turning on a switch A, then the needs to be go to the output 1. For switch B, something like that, it will go to the switch tank B, like that. It happens. So based on the select in same in multiplexer and demultiplexer also, based on the select lines, it selects the input that is receiving for in the multiplexer or demultiplexer is like is destined to go to that output or of multiplexer or demultiplexer. Based on this switch or select line only, everything going to happens. Okay. So here in this example, what example I gave, right? So here the water is the input thing, the water is the input. Okay, so switch will be the select line. Okay, why? Because switch is designed into like that, where should be water to be stored, right? In which tank it should be stored, right? So switch will be acting like a select lines, and the tanks are the outputs. Output means y. Okay, in your multiplexer we have number of outputs, right? Many number of outputs. So just like the tanks in what I gave example, right? There will be four tanks, right? So just like that, your tanks or your output. Okay. So this is exactly how the DEMUX works. Okay. So see here, example, the water is coming, right? Is considered as an input, and control means select line, a switch. Okay. If you turned on switch, okay, like for and select tank 3 means it will goes to like red box, right? You can see a red box here. It will goes here. Okay, like that happens. Based on this select line only, everything is going to connect. Okay. So okay, comparison between mux and demux. Okay, so what is the difference between mux and demux? Many to one. How direction works? Many to one means many inputs, only one output. Whereas in demux, one input, many outputs. Okay, like we have explained some of the multiplexer like 2 is to 1, 4 is to 1, 8 is to 1. So in that we have like number of inputs increasing as the design of that particular mux become complex, right? So whereas in DMux there will be one inputs, only one input. Okay, whereas in outputs it occurs like y for mux and DMux. Okay, so the main difference is, okay, in multiplexer. Okay, in multiplexer we have n number of output, sorry, inputs, right? Only one output. So in that, what is the goal of the select line? The major goal of the select line is to select an input. Okay, select an input that need to be passed to the output. Whereas in demux we are going to select output that will take the input. Okay, that in which the input should be stored, like that. Okay. So the difference between mux and demux is the select lines will select input here, whereas in demux it selects the output. Okay. So functions, it combines multiple signal. Multiple signal means input one, right? So we have n number of input. Okay, n number of input coming to like that part of the multiplexer, and there it's combining and choosing, select line is choosing which input should be passed, like that. So it's telling function is combine multiple signals, whereas in demux only one input is coming. So in select line is thinking that, oh, this input needs to be go to that particular output based on select line. So it's telling to that, so only one input is coming, so it try to distributing it. Okay, and distributes after distributing based on select lines, where that one particular signal will go into the particular output which select line is selected. Okay, so for best example I explained like TV remote, right? TV remote, like think you have n number of inputs, like you can press 1, 2, 3 home button, exit button, right? So based on your pressing, set top box receives only one signal, right? If you press one means one, and it will show the one, right? Like that, it has many inputs. Okay, then you are the select line. Think you yourself as the select line, and you're going to select what number you want, and that will be passed to the output. Whereas in demultiplexer, just now I gave a simple example like water tank. So yeah, That's how demultiplexer works. Next, if you are going to talk means, yeah, this will be the DEMUX block diagram. Okay, so see here, it has the block diagram shows the good, right? It has one input. This is the 1:2 demultiplexer. Okay, one input, two output. Okay, and select one select lines. So yeah, this is the port details. Okay, D1 means it has one bit. Okay, like now I'm mentioning about like what that input can carry. Okay, it can carry one bit of data, and this also everything in this demultiplexer can carry one bit of data. Okay, so and direction, D in means input, select means input, and Y0 output, Y1 is output. Okay, we have two outputs here for demultiplexer as per the 2:1 we are studying. So we have two outputs. Okay, so and I will explain this. Okay, see here when I explain truth table. This will be our truth table of 1:2 D works. Okay, how this works? Same as in multiplexer. This also only based on the select lines. Okay, see here. If your select line is 0, then you are going to get Y0 as D in. Okay, for 0, select line is equal to 0. You are going to get Y0 as D in. Okay, so if you pass for select 0, see here, if select 0, if you have D in 0, then you have Y0 also 0 means now you can't know why it is not D in. But see here, if a select is 0 and D in is now 1, now you have Y0 is equal to 1 because what the two table defines, if you select is 0 means Y0 is equal to D, Y is equal to Y0 is equal to D in, and other outputs will be 0 that time. If select line is 1, then Y1 is equal to D in. Okay, just keep that in point. You can easily remember this two table. Okay. So yes, I have something mentioned here note, right? See here, just what I explained that is in there. Okay, select is 0, right? Now we have D in 0. Okay, no signal is passing, so both are turned off, 0 0. But select is 0, D in passes to, we have D1, right? So it will pass us to Y0 only. And this is the like truth table what I read in my like what we read in multiplexer, and this will be going to same as in 1:4 multiplexer, but there we are going to use binary logic like how we used in 4:1 mux, like that only we are going to use in DEMUX also for 1:4 DEMUX. Okay, called binary logic. Okay, do you guys remember that binary logic? Like for 0 0 means of course it's 0, 0 1 means 1, right? Like that it's going to depend which like input where need to be passed, like for outputs y0 y1 y2 y3 will be there, right, in 1:4 DMAX, like that. Based on that select line decimal binary value, that input will be going to that particular output. Okay, so yeah, next coming to the boolean equation means how we are going to do this boolean equation. You guys, you need to find out how to derive this boolean equation on your own. Okay, so this is going to derive by using truth table only, but you should have know the idea like how we are going to derive. In previous class I explained for mux and add gate or gate, like that, right? So see here, now we have select line is 0, right, and d in is 0. Okay, so what is the and of this select and d in? If the what does the and truth table says? It says for if the both values are 1, then the output will be 1, right? So that's it. This is how it's going to work. Okay, so if select line d in, okay, select both are 0 means you are going to get y0 is equal to 0. Okay, if both uh, select line is 0 and d in is 1, okay, now you are going to get 0, but in truth table you have 1, right? So based on this truth table values, you are going to change that boolean values. So what we have changed, we have applied not to the select. When you apply not to the select, what it becomes, both the values are 0. If you apply not to the cell means cell 0 0 will becomes 1, and 1 and of 0 will become 0, right? Okay, now this equation solved. For now you have 0 1. If select is not means inverting, right? 0 to 1. Okay, now it's become 1, and our operation of select with d in, then it will becomes 1 and 1. 1 and of 1 will becomes 1, right? Now you are getting the truth table value, right? So this will be the your final boolean equation. Just like, if you are guys getting doubt here, I know, like, why do we have two boolean equations? Just go back some previous classes, okay? How many outputs we have in multiplexer? One, right? AND gate one, OR gate one, NAND gate one, right? So you add only one output. That is, you are taking as y and writing the boolean equation of that truth table. But now in DEMUX, you have, for 1:2 DEMUX, we have two outputs. So you should have two boolean equation for that particular output. Okay, so that's how you are going to write a boolean equation, and same goes with y1 also. Okay, based on the truth table only you are going to get this boolean equation. We will just try. Okay, what is the boolean equation? D in and cell, right? So okay, boolean equation, when the it's going to work for y1, when the cell select line will be 1, right? Okay, now you have select line is equal to 1 and d in is equal to 0. Then if you apply AND operation here, 1 0 means values are changing, right? So output will be obviously 0. AND operation only works for when both the values are same, right? Now we have 1 1, then you are going to get 1, right? Like this, how you are going to derive a boolean equation. Just to remember, I told you y0 will going to receive the input only select line is 0. Okay, y1 will only receive 0, sorry, input when select line is 1. Okay, just remember this point. Okay, and for other cases, like for when select line is 0, what will going to happen to y1? Obviously it will become 0. Why? Because what is the that cell is doing there, it's part to, like, it need to select the output, right, in demultiplexer, whereas in multiplexer it's going to select input, but here it's going to select output. So this input will only pass it to y0. Why? Because select line is selecting only y0. So of course the y1 will become 0 during that select lines. Why? Because nothing is passing to it, right? It's in the ideal state. Okay, so it will always be 0, like that, how it works. Okay, just remember. Okay, like this is the simple logic diagram. Okay, what we have, two AND gate and one NOT gate, right, for selecting. Just this picture doesn't seems like a logic gate, like a logic gate level implementation, but you need to try. Okay, just how AND gate, and you are going to pass one input to it. Okay, uh, this, like, while I generating this image is not properly generated. Okay, so don't think about these and lines. Okay, Yeah, coming to the verilog code. Okay, so this is how you are going to design. Okay, in verilog code we have a design part and a test bench part. What is the purpose of design part? To design an hardware. Then what will be the purpose of test bench part? The purpose of test bench part is to simulate that design using different test cases, right? So why we need to stimulate that particular design code? Because before deploying that design, we need to check whether that design is working properly or not with like what you know about that okay test cases, right? Using every test cases you need to derive that design. Okay, and after like running every test cases, if it passes means then only it is the as the like chances to deployment. Because after deploying in while explaining the some basic rules of RTL, I did mention about some part, right? At last step, do you guys remember the last step? Yeah. Okay. Tell me what is the last step in the chart. Okay. Those who have present for the early classes watching my videos, what will be the last step there? Guys in the chat, can anyone? Guys, is anyone listening to my class right now? Just answer the question, okay? If you know, then answer the answer, okay? Or else just say, sir, we can't remember this time, okay? Guys, no one is there. Yeah, while explaining the RTL design flow, right? I did mention about the 7 steps, right? Do you guys remember like fabrication, synthesis, simulation, like converting Verilog code? What will be the last step? Okay, just answer that. Okay, I will only just answer. Do you guys remember that tape out part where I just mentioned, right? Tape out part. That is the level we are going to generate and files, right? Like design files to deploy. So if you find a bug or error after generating your design, okay, think now you have generated design for a demultiplexer, and now you are going to like after applying that RTL design flow, like first what does the first step in RTL design flow? Specifications, right? Second one is coding, RTL verification simulation, and after that logical synthesis, right? Like after applying these in every steps, when you go to the tape out, okay, tape out section, okay, like where you are going to uh, implement the design code what you have generated hardware component to deployment, right? If you find a bug there, I did mention that it will cost 100 times more than while you are at logical synthesis, right? While verifying that RTL simulation, right? So that's why we need test bench. Why? Because before going to that stage, okay, final stage, if you find that error or bug in that particular code or your hardware design, then it will cost more, okay. So to prevent that, you are going to use test bench. Why? To check whether that code is working properly or not, okay. That was my point to just go for previous classes, okay. So now we are going to like yeah, coming back to the top. Here we have DEMUX, right? Oh, so you are going to write a verilog code. How we are going to write a verilog code? First, you need to create a module. What using this module keyword, it's going to create an hardware block. Okay. So what is the hardware block of that particular module? DEMUX 1x12. This is the random name given. You can mention any art like a name you want. Okay. So and inside that module, okay, you need to mention what are the components that are like ports that particular hardware block has. Like now you are going to create 1:2 DMX means obviously it will have input D in and select, okay, and output as Y0 and Y1, right? So yeah, you need to mention that. See here. Here now, in previous classes, I explained something about wire and edge, right? So here we don't have mentioned anything called wire and edge, but default there will be one value, right? If you don't mention anything, then what will be that value? Can anyone answer in the chat? Yeah, wire. Yeah, good. See here. If you don't mention anything in front of that particular port, okay, input port or a select line or output port, then it will automatically by default it has wire, okay. What is the work of wire? It acts as a physical connection, okay, like it's like a something actually called as wire, like the name itself says that what is the work of that, okay, port. Wire means it's connecting to ports, right? So the wire itself, the name itself says that the work of that port, okay. So after that, we are now using a simple, okay, simple assignment statement, okay. You can also write this code in the form of if else using assign block, okay. Remember, if you are using an assign block, okay, assign block inside a design code, then the output you need to mention reg, okay. Just remember that, okay. So assign y0 is equal to, you are going to implement that boolean equation here. Why? Because you are going to design the code and test the code based on that truth table, right? So you have some equations generated like that are called as boolean equation based on the truth table only. So you need to use that equation, okay, for testing, okay, whether what will be the y0 value, y1 value when you have some random test cases, okay. After that, you need to end that module, okay. Now you have created a hardware block, okay. After creating hardware block, you need to uh, check the like go for a simulation for this hardware block, whether the every like for every cases is it generating a like correct output or not, like that you need to check. For that, you need to create a test bench code, okay. And this is our test bench code looks like, okay. Now don't think why is there something called as time scale 1ns on ps, okay. I will explain this when I explaining the encoding, okay. Encoders, decoders, like concept will be the next concept. So at that time I'm going to explain this. Just don't think about this, okay. So yeah, coming back to, we are going to create a test bench module, okay. After creating a test bench module, you need to define that input values, okay. Why you are only giving reg in for the input values here in test bench? Why? Can anyone answer that? Okay, I will only say. Why? Because see here our input is changing, right? For every input value is changing, right? In our while to be test casing. So to remember that value, okay, to remember that value of like before it's going to change, at least you need to remember that value to the point where it's going to change. Okay. See here, first step you are going to assign as d in 0, cell is equal to 0. So it should remember to where it should remember that point value until you apply another input values. Okay, change that input values to that it should remember, right? So you're going to give a range as always. You will in every code you're going in test bench code you're going to give range for input values and wire for output values only. So I'm just remembering you guys that why you should range. Okay, so because we had 2 days gap between the classes. Okay, so okay, I need to mention something. Okay, so next Saturday, like this Saturday, some your guys will have on simple test. Okay, just the concepts we have covered till Friday. This Friday, you guys going to have simple test. Okay, based on like till the concepts you will have test. Okay, just don't forget to attend. Okay, see here. After that, you are going to create a design under test block. Okay, how we are going to test using UUT. What does UUT means? UUT means unit under test. Okay, so you are importing that particular. This is the design name. Okay, design hardware block name which you are correct created in while doing a design code, right? This is the design code, right? Look, this name is imported here. Okay, why we are imported? Because that is the hardware block you are going to test, right? So you need to like if you give this in the form of life, you are going to mention this design block name, and you are mentioning UUT means unit under test. Okay, what does means and how that computer understands UUT, unit under test. Okay, you are mentioning that I have imported this hardware design DEMUX. Okay, this hardware design. Okay, I have created and imported here. So I am taking that design into test. Okay, UUT means that only. Okay, so now inside that you are going to use like mapping the inputs, outputs, and select lines. Okay, so what is this called as mapping formatting? Okay, you can write here like d in comma select comma y0 comma y1 like that also, but sometimes what happens, it's going to create an error. So to avoid that error, you need to use a formatting structure. Okay, that is called as map formatting. Okay, you are telling that like you have written something called dot d in bracket inside d in, right? So this means I'm going to connect it, our test bench d into to the design d in. Okay, so I'm mapping that d ins of particular test bench and design code. Okay, like that this means. Okay, so after that you are going to telling the your test bench code is to now I am going to test. That was this initial begin means. Initial begin mean only starts the code once. Okay, after it starts it's going to test for that particular test cases. What happens if d in 0 and selection is 0? What will be the output? Output you are going to get is y0. Why? Because you have select line 0, right? Select line 0 means what you are going to get? Sorry, if d in 0 and select 0 is means now your d in is not passing anything, right? So if you are not passing anything as an input, then everything will be 0, right? Y0 also 0, y in also 0. Where now your d in is generating one bit input, and your select 0. Select 0 means it's going to select y0. So you are getting y0 is equal to d in. Okay, then your you are selected y0 port, whereas now you are d in 1, where select is 1. Okay, when select is 1, what is the value you're going to get? Of course, your y1 output will be in the contact, right? Will be connected to the input, right? So now we have 1, then it will be generating. Just don't think why I have don't have another test case. Okay, just think. Okay, what will be the another test case? D in is equal to 0. Select line is 1, right? So what is going to that produce? That will produce same, right? Y1 is equal to 0 and y is equal to 0. So that point is going to done here only. Why? Because if d is only turned off, then select line has no control over output, right? Why? Because you're not generating anything here. You're generating value d in is 0, right? Then you're not going to pass anything to the output, right? So just to keep the code short, we have like this. If you guys have confused means confusion in this code means, you can write that another test case also, like d is equal to 0, select line is equal to 0. Just to keep the code short, we have implemented like this. Okay. Okay. So you know about display, right? Display means it's going to tell the code that yeah, you're going to print this done statement. Okay, after testing every input values, every test cases, you are able to display finish means yeah, I am done with my test bench. Now I am going to end this code. Okay, this will be the difference between finish and display as explained in the previous classes. Okay, end module means it's going to end that particular design code. Okay, test bench code. Okay, so coming to the waveform, like as the waveform means it's like visual representation of the particular truth table. Okay, how the operation will be conducted like that. So look here, now your d in is in off state 0. Okay, and your select line is also 0. So what will your y0 will become? Y is like when your d in is 0 means both your y0 and y1 will become 0. Look here, you can look that, right? After when your d1 is passing some input values, then your select line is 0. Then what is going to select? It's going to select y0. Okay, based on select line, you're going to select a particular output, like that how this waveform works. Okay, so you can view this in EDA playground using that something mentioned about EP wave, right? Generation of EP wave. How to generate a EP wave using dump where file, like dump where, right? Dump file, dump where, right? Just using that, you can see that how that is going to convert in the form of signals, right? How that input and outputs are expressed in the signal, right? Just practice yourselves. Okay, so after completing with this 1 is to 2 DEMUX, if you have better view of that DEMUX 1 is to DEMUX, you will get understanding of 1 is to 4 and 1 is to 8. Okay, because it has same patterns. Okay, just you are going to increase outputs here, whereas in mux you are going to increase input. Okay, same pattern. Okay, just follow the same pattern which you have learned so far and apply it. Okay, you will just truly go to these concepts. Okay, 1 is to 4 DEMUX. 1 is to 4 DEMUX means 1 input, 4 output. Okay, and there will be 2 select lines. How we are going to get 2 select lines? Based on the equation 2 to the power n. 2 to the power n means what is the, how can you write 2 4? Okay, you have 4 outputs, right? How can you write that 4? 4 can be written in the form of like if you are going to convert that something into 2 powers, then you are going to write it as 2 to the power 2, right? So you have equation called as 2 to the power n. So if you are equating that 2 to the power 2 to 2 to the power n, then if you match that values, then of course you have n, you will get n value is equal to 2. So like that you have two select lines. Okay, so here you are writing the 2 to the power n comparison to the outputs. Why? Because in DEMUX select lines is based on outputs. Okay, why? Because select line is going to select the output, whereas in mux it's going to select the input. Okay, that's why we're comparing with the outputs. Okay, after that truth table. Okay, truth table, yeah, see here how does this truth table works. Okay, I did mention about something called as binary forms, right? See here, your select line s1 and s0 is 0 0 0 0 means the value is 0, right? So why are you getting everything is 0 here? Because here, look at your value d in. D in is 0. D in is 0 in means no input. If you have no input means no output. Yeah. After that, see here, both are 0 0 and you have D in is 1. Okay. Then what will be this 0 0 of S1 and S0 value will become 0, right? Decimal value. So 1. Binary value will become 1, right? For now, your D in is 0, so everything is 0. After that, 0 1. Okay. Now you have 0 1. What is this binary form? What will be this 0 1 when you convert it to decimal will become, it will become 2, right? Sorry, 1, right? So now we have y1 is equal to 1. Only when your select lines is generating like some values, and if you get that decimal value of that particular binary values. Okay, now these are the binary values. When you get convert them into decimal numbers, you will get some values, right? So based on that value only, yeah, you are going to decide which output you are going to choose. Okay, now 1 0 means 2, you're going to choose 2. 1 1 means 3, 1. Then guys, just tell me what will be the value of triple one. Triple one. Guys, be fast, okay? Yeah, 7. Yeah, good. Okay. Then where does this triple one comes? It will comes in while you are using 1 is to 8 DEMUX. Okay. Just how you have learned that concept in 8 is to 1 marks. Just like that, you are going to get three binary values. Okay, three binary values like you have, there will be three select lines, right? S2, S1, S0. For combining that binary values, you will get some values, right? So based on that value only, you're going to choose that port, output port. Okay. Okay. Now you in 1 is to 4 DMAX, you have 4 outputs, right? So if you have 4 outputs means you need to create 4 Boolean equations. Okay. So based on truth table only you are creating. Okay, I will tell how this first two works. Just practice this y2 and y3 and figure out how it's going to work based on the truth table. Okay, what do we have? Okay, we will create our own boolean equation. Okay, based on the truth table. See here, for y0. Okay, when you want the y0 output, what do you want? You want select 1 0, select 0, d in, right? So you're going to write a equation, boolean equation, in the form that your y0 should be on. Okay, if you solve that particular boolean equation using this two table data, then it should be, then that y0 should be works. Okay, just when that y0 will be turned on, then what will be that y0 Boolean equation? So y0 is equal to 1, right? Look at this line. Only when you have s1 is equal to 0, s0 is equal to 0. Okay, d1 is equal to 1. You have y0 is equal to 0. Okay, so just look here. What will be the and of s1 and s0 will be becomes 0, right? Why? Because and operation will only work when you have both the values to be 1, right? So after you are getting 0 from both s1 and s0, you are going to apply and operator with d. Okay, so 0 and 1 becomes 0. Okay, now it's not working. Just change that, apply some not get there. Okay, if you apply s1 also not get, s0 also not get. Okay, both will become 0 to 1, right? So s1 not and gate of not s0 will becomes 1. Okay, if you apply combine that two value to do in and apply and gate, then you will get 1, right? So what will be that y0 equation will becomes not s1 and operation not s0 whole operation and operation with d in, right? That's what it's become here. D in and operation, just I read this in the equation in reverse order. What is telling D and of not S1 and of not S2. Just like this, it's going to work, right? So figure like just like that. How I told you y0, just like that only. You need to figure out for y1, y2, y3. Okay. So after describe this will be the block diagram. Okay, and guys, just practice the gate level implementation. Okay, like using and gate. Okay, and gate not gate. Okay, and that was something I mentioned in previous classes, like gate level implementations, right? Even though it's like for your you to know how the thing works and how many logic gates if you are going to use, you need to write that code, right? You need to remember some, like how many logic gates you are going to use for building that block, right? Just remember and practice. Okay, so in DEMUX, how many logic gates you are going to use, just figure it out. Okay, tomorrow in tomorrow class I will ask. Okay, I need the answer. And after that we are going to write a verilog code, just like for 1 is to 2, you are going to create a design block using module and mentioning the input and output values. After that you are going to assign. Okay, and after assigning you're going to mention every output boolean expression, and after that you're going to end a module, just like how this will be the similar pattern for writing a verilog code. Okay, just if you know once like how that works, you're like writing a code in a way is very easy in verilog. Whereas if you have someone from CS background, like learning C, C++, Java, Python, then they have different concepts and topics. Okay, so but in Verilog code, it will be easy. Okay, if you learn how the basic Verilog code works, means you can figure out based on that particular topics knowledge. Okay, like using truth table and Boolean expression, everything you can write code on your yourself. Okay, so after that, okay, you are now use time scale, right? Like from concepts to concepts, we will just add one line to the code. Okay, okay, in previous classes I have said about finish monitor, like that, and after that we added some code as dump variable, dump file, right? Now we are using time scale, right? Just try to figure out what this will be. If you guys don't get means, I will explain in the next class. Okay, while you are learning encoding and decoding. Okay, so just like using same concept, you are going to create a model for a test bench. Okay, and just like mention port, naming the ports like reg and wire. Okay, if you have inputs means them mention them as reg or as output as wire, and you're creating a unit and a test, and using map formatting. Why? Because the mapping design inputs to test wise inputs, and after that you are going to begin that test case using initial begin. After beginning, you are going to test that outputs. Okay, so using that hashtag 10 means everything, everyone will know, like hashtag 10 means it's the buffer time. Why? What buffer time is? How does it works? So now you are testing d in 1, s1 is equal to 0, s0 is equal to 0, right? So after designing this test, okay, you are telling to your that hardware block, okay, that code, you're telling the code or hardware block that, yeah, now you have tested, you have tested this case, right? Just take 10 units of gap, okay, before starting the another. Okay, why? Because just like you're creating a delays. Okay, so if you are creating a delays means you will get the every signal that has generated, okay, like complete signal you are going to get, giving a time to code, giving a time for that hardware block to recover. Okay, yeah, now you tested that, wait for like giving a some releasing pressure. Okay, okay, just think about releasing a pressure and giving a time to recover, okay, from that previous test case, and now you are changing the test case like that. Why you need to give buffers? Okay, and after that finish end module. Yeah, this how it works. And tree diagram, right? You have learnt using 2 is to 1, like for 4 is to 1 multiplexer you have built using 2 is to 1, right? Just like that only, practice this DEMUX. Okay, you are using 3 1 is to 2 DEMUX and build 4 is 1 is to 4 DEMUX. Okay, okay, this will be the sum of the applications of DEMUX. Okay, where you are going to use it in the real times. Okay, just note down these applications. Okay, well, you're going to use the DMUX, data routing, memory selection, communication, display system, IO expansion, SGPA and VLSI design. Okay, yeah, this will be some of the application. Okay, like this one was the concept, like this will be the application in some interviews. If you are attending for a VLSI designer means they will absolutely ask the application of DMUX, right? So just for remembering purpose, just note those this point. Okay, yeah, okay guys, yeah, I have mentioned like this will be common questions, okay, that they are asking in interview questions, okay, for based on demultiplexer. Like what is demultiplexer? How many select lines does 1 is to 4 demux need? What is the Boolean equation for? Yeah, that concept which I was explained, same only they're going to ask. Okay, and how is different? Demux is different from decoder. Okay, this one question we will know when we are learning about decoder, right? After encoder we have decoder. Okay, so at that time you will get the idea of this how is different from decoder. Okay, just don't think about this. Okay, so keyword assign is used for, like I said, right, for continuously assigning the value you use assign keyword, right? After that summary basics, right, what we have learned so far, like that. Okay, for this class this is enough guys. From next class, okay, we are going to start encoder. Okay, that is such a wonderful concept. Okay, like you can learn